Hello. Okay, let's get started. So Unit 1, our essential question is, how can you tell if two quantities which appear to be different are the same? And today's aim is for lesson 1.6, how do we divide polynomials? Pretty straightforward. We started talking about this already, so you're going to see some of the examples are going to look very familiar. We also took a fluency on a little bit on this topic. So we're going to include some other things as well. But like, for example, 1, you've seen something like this before, so this is going to be more practice with negative exponents. So example 1 says, write using only positive exponents in a simplified form. Okay, so first thing I always want to do is get rid of the negative exponents. So I see -3 and I see a -2. So in order to get rid of the negative exponents and make them positive, I just want to flip the base where that variable is, or where that quantity is. So x to the -3 is going to go down to the bottom, and x to the -2 is going to go up to the top. Nothing else changes, only the things with the negative exponents. So when I rewrite that, I have x squared times y to the 4th over x cubed times y. Okay, now I can keep going. So now I can divide quantities that are alike, meaning quantities that have the same base, I'm going to subtract the exponents of. So I have x squared on the top, x cubed on the bottom. If you remember, we talked about this. What we talked about is, think about the difference between them. So down here, that means there's 3 x's being multiplied. Up here, there's 2 x's being multiplied, which means that I'll have 1 left over on the bottom. You can write them out if that helps you, and then cross out however many you can. You see there's 1 left on the bottom. Okay, and for y to the 4th and y alone just means that it's y to the 1st. So the difference between 4 and 1 is 3. And since the bigger exponent's on the top, what's left over is on the top. So we got y cubed over x. Let's go on to the next example. So example 2 says to divide. I want you to notice something. Notice that the top is a polynomial. Not something we looked at yet when we're dividing with a polynomial. The bottom is a monomial. Polynomial means multiple terms, monomial means 1 term. Okay? So the way that we divide right now is going to be specific to when we're dividing by a monomial. That's important to remember. When we're dividing by a monomial. So this is all 1 term on the bottom in the denominator. -6x squared, y squared is all 1 term. That's a monomial. So if I want to divide by that, I need to divide everything in the numerator by that. So we're going to go kind of step by step. Notice here there's 3 terms on the top. 1, 2, 3 terms. Remember, terms are separated by addition and subtraction. So that means I have to divide each of those 3 terms by the denominator. So let's start. I'm going to divide 18x cubed y to the 5th by -6x squared y squared. If I divide the 18 and the -6, I get -3. If I divide the x cubed and the x squared, I just get x to the 1st. And if I divide the y to the 5th and the y squared, I get y to the 3rd. Now we're going to move on to the second one. We're going to divide the second term by the denominator. 36 divided by 6 is -6. I think I said that wrong. 36 divided by -6 is -6. X cubed divided by x squared is just x to the 1st. Y to the 4th divided by y squared is y squared. Then lastly, we're going to divide the third term by the denominator. Notice when I'm circling these, I'm including the sign in it, the sign of the term on the top and the sign of the monomial on the bottom. -6 divided by -6 is 1. X squared divided by x squared is 1. Y squared divided by y squared is 1. So technically what we have here is 1 times 1 times 1, which I can just write as +1. Here's a common misconception. Oftentimes, when we see something like this, something divided by itself, we want to say that's nothing, that it just goes away. Well, it doesn't just go away. What it does is it divides out. When I divide anything by itself, 5 divided by 5, I get 1. X squared y divided by x squared y, I get 1. So I have to remember, I need to keep that positive 1 there as kind of like a placeholder. So when I divide any number of terms, in this case 3 terms, by a monomial, I should get out the same number of terms as the numerator. So notice this has 3 terms, just like the numerator had 3 terms. So here is a big common misconception, forgetting that plus 1 at the end. Forgetting that when you divide something by itself, it's not 0, it's actually 1. Okay, we're going to do one more example together. This example is a lot like ones we've done before, a little bit more complicated maybe. So what I notice is on the top, I have a bunch of things being multiplied and they're kind of separated by parentheses. So I'm just going to multiply them all together to make it a little easier for me. So 4 times 3 is 12. A, I can't multiply with anything, so I'm going to keep the A there. B squared and B is B to the third. And then the C I can't multiply with anything, so I'm just going to put it back there. And then the bottom I'll just rewrite because there's nothing to multiply on the bottom. Now the next thing I'm going to do, I see a negative exponent. I want to take care of that right away. I don't want to let that linger. So I'm going to move this up to the top. It doesn't mean that I move the other A down to the bottom. That's a common misconception. Only the thing with the negative exponent switches spots. Nothing else does. Also common misconception, we talked about this, but oftentimes people think that 6 should then move to the top because it is next to the A to the negative second power. But the 6 does not have a negative exponent. The exponent for the 6 is actually just a 1. Okay, so let's keep going. So I'm going to move that A to the negative 2 power to the top. So we already have an A to the first. Now we're going to have an A to the positive 2 power. Then we have B cubed, C to the 4th, all over 6B cubed. Okay, now let's start dividing. Actually, before I do that, this is A cubed, so I'm going to just rewrite it with that. Okay, now let's keep dividing. So I'm going to rewrite it over here. So 12 and 6, when I divide, I get 2, and that goes on the top because the 12 is a bigger number and it's on the top. A cubed has nothing to be divided with, so I'm going to keep it there. B cubed and B cubed. We just talked about this. When we divide something by itself, we get 1. So you may be asking yourself, where do I put the 1? Do I put it on the top? Do I put it on the bottom? Well, in this case, it doesn't actually matter. If I already have things in the numerator, I don't necessarily need anything in the denominator. So I could put a 1 down there, but like writing the number 2 and the number 2 over 1 is the same thing. So the 1 in the bottom is not necessary. 2 is not equal to 1 over 2 though. So when you do have 1/2, you have to make sure that 1 is in the top. Okay. So then we have C to the 4th, which also remains in the top. So because the 1 is on the bottom, I don't have to write it. Okay, so if you notice the difference here, B cubed divided by B cubed, I didn't necessarily have to keep the 1 there. But for the last example, we made a big deal about keeping the 1 there. That's because this example had multiple terms. So that 1 is holding the spot of a term. This is all one term. Our answer is all one term. This is a monomial. So having that, I just spelled monomial wrong. Monomial. I'm a bad speller. Okay, so having that 1 there wouldn't make a difference. If I wrote times 1, it's kind of useless to write. That's why I don't need it there. Okay, guys. This is it for lesson 1.6, and we'll see you tomorrow.